Good afternoon and good evening to all my friends in this part and also in the eastern part of the world. We are here for the second edition of 10 Talk for the year 2023. And for a change, we are having a workshop on standards, IEEE standards particularly, which we have thought of quite some time back. But now it has been possible because we could have on board Srikanth Chandrasekaran, the man who had been leading the Standards Association right from the front. With these words, we have with us Professor Takako Hashimoto, the Regent and Director-elect. And may I request you, ma'am, to make the opening remarks. Ma'am.
Okay, thank you, Sanjay. And hello, everyone. Good afternoon, good evening. I am Takako Hashimoto, Region 10 Director-elect. And thank you so much for joining us today, Region 10 Talk. So today's topic is why IEEE standards matter. So the standards is very important, as you know, for us, for our life, and of course for IEEE. And today we could have a very great speaker, Srikanth Chandrasekaran, Mr. And he is a very smart researcher and engineer and is expert on the standards. So I'm sure that we can learn a lot of things from his talk, and we can discuss the fruitful things during his talk, this Region 10 talk. So let's have a great discussion after his talk, and I look forward to having a great time with all of you. Thank you so much.
Thank you, Takako-san. I would just move on to the main program, and I would just introduce the speaker, and then we can just start the session right away. Today's speaker, session conducted by Srikanth Chandrasekaran. He prefers to be identified as Sri. He is the country head of IEEE India and Global Lead, the Foundational Technologies Practice, IEEE Standards Association. Sri has been associated with IEEE since 2012 and is currently heading the IEEE's business operations in India. Currently, Sri heads IEEE India organization and also leads the Foundational Technologies Practice within the IEEE Standards Association, with its mission on building end-to-end trustworthy systems with focus on identity, privacy, and cybersecurity. His practice focuses on emerging technology areas such as quantum computing, AI/ML, IoT sensors, blockchain, and more recently, metaverse, and leads Standards Association's efforts in the Asia-Pacific region. Sri leads the IEEE Blended Learning Program, an e-learning initiative focused on bridging skills for students in emerging technologies and lateral skilling of industry professionals. Prior to joining IEEE, Sri was associated with Freescale Semiconductor Incorporation, formerly Motorola, for 17 years, managing a global electronic design automation R&D team based out of Adelaide, Australia. Sri received his Accelera Technical Excellence Award in 2009 for his leadership and contributions to design automation standardization. Sri holds a Bachelor of Science degree in physics from Madras University, India, and master's degree in electrical communication from very prestigious Indian Institute of Science, Bangalore, India. With these words, I request Sri to kindly take the stage. That's Sri. Sri, please.
Thank you, sir. Thank you, Sanjay ji. Firstly, I want to thank Region 10 for giving me this wonderful opportunity for having a chance to discuss about standards with the Region 10 membership. It's a great honor for me. I'm really humbled by this opportunity. To be fair, this discussion started with when Deepak Mathurji was the Region 10 director 2+ years back, when we had decided a fairly intense standards program, little knowing what was around the corner over the past 2 to 3 years. But finally, I'm glad that his vision that he initiated back in 2019, 2020, we are able to fulfill that under the leadership of Professor Lance Fung. And for that, I'm thankful for Lance Fung and the Region 10 leadership for allowing me to discuss about IEEE standards. I won't go through my bio. I think Sanjay ji has already mentioned it, but I just want to mention a couple of things. I am also a member of the IEEE. I'm a senior member. I've been a member for the 20 years. And one of the last bullet point is important. Today's discussion, as per the IEEE Standards Association bylaws, the views that I'm expressing in this talk are my personal opinion. I am not representing officially the organization. I just wanted to make it clear. So what we are going to do, we have scheduled it for 2 hours. I'm hoping that we can have at least half an hour of Q&A, that will allow people to post questions. I assume that this is a one-way broadcast. So attendees for this presentation, they will have an option to post, messages on the WebEx chat. So please do post questions as you see them. And during the moderation, we will take up the questions and try to respond. I'm sure that there are questions I may not be able to respond. Always there are a couple of questions that I have not thought about previously. And if that happens, I will certainly look back with Region 10 and get those responses that people are looking for. This is the brief agenda. And so I discussed with Sanjay ji, and we thought at some point of time, we will give a 5-minute break, and I will let Sanjay ji manage that if that is required, and we will proceed accordingly. So I will give a brief overview of the IEEE, then introduce in fair bit of detail on the IEEE Standards Association. Then we will talk about the governance, the process, and the programs. And it is just not useful to talk about governance and the process, but I really wanted to highlight some of the very key and very current standards initiatives that are going on. And since this is a program that we are, where there are a lot of students who are participating in this program or might be listening to this recording session later, I just thought I will have a few of my thoughts on, why it's important for the engineering student to think about standards, right? And then we'll have Q&A, okay? So, of course, when I introduce the IEEE, we are all experts here in IEEE, more so you than me. But to complete the whole picture, I thought it is important to talk about the context we are coming from, and then dovetail into the standards part of the topic. And the first few slides, people are probably very familiar, but I just wanted to reiterate that. We are certainly close to about 430,000 members at this point, and we are there in every country. And sometimes we talk about it just lightly, but I have been in situations where it's been amazing. It's been a wonderful experience. At one point of time, I had an opportunity to go to West Africa. There is a small landlocked country called Burkina Faso. And to be fair and honest, I wasn't aware of this country until there was a meeting that was happening there with one of the African bodies, and IEEE Standards Association got invited to attend that meeting, and we thought it was important for us to be there for the region. So I went there, and the day I landed, I found that there is an IEEE section there, and there are members of the IEEE who wanted to meet me there. And that really, immediately I was in a foreign country, but it completely felt at home, right? So it is, it's quite amazing when we know that IEEE membership goes broad and deep. And our vision is to be a global technical community of technical professionals who are universally recognized for the contributions of technology and the technology professionals in improving global conditions, right? And to dovetail on that, I just thought we will just talk a couple of minutes about role of engineers in society. Of course, having said that, today IEEE is much broader than just engineers. I do want to recognize that. At one point of time, it was all about electrical and electronic engineering. But today, even within engineering, we cover several aspects of engineering, whether it is biomedical or aerospace, social implications of technology. There are quite a lot of things that we are doing. And in that context, the role of engineers is in advancement of technology for improving the standards of living and the application of knowledge innovations to create opportunities, job, and wealth for the well-being of the people. Today, definitely, we are living in a world where everything we touch, feel, and experience is engineered. I don't think there is any industry vertical that is not being touched upon by the internet or the Internet of Things or any of the technology that are being developed around the world. We definitely are a global community. We are known for our publications. We are very well known for our technical standards. I will deep dive into that. We are very, very well known for our humanitarian work. And of course, we are strongly supported by our technical societies. IEEE has 39 technical societies and about 7 councils, which look at all sorts of aspects of engineering and technology. And we are a membership organization, and like an event like this where we are doing a workshop, we organize quite a lot of conferences. I understand that at this point we do about 2,000 conferences a year. So if you reflect back on it, it is about 4 to 5 conferences in a day that's happening around the world, and that is pretty significant. And within Explore, and many of you might be accessing Explore, I think it's now at this point, it's close to 5 million documents that we have with more than about 11 to 12 million downloads in a month. So that's a significant impact. And I just mentioned it, like today we are much broader than electrical electronic engineering. We are talking about smart grids, industrial systems, life sciences, nanotechnology, but even in the new era, we are talking about AI, machine learning, metaverse, sustainability. These are really taking center stage today, and there is a lot of technology around it and a lot of work that professionals, whether they are engineering professionals or professionals coming from other fields, need to come together and deliver work around these aspects. We have quite a lot of journals and technical publications, about more than 180 plus journals. I'm sure a lot of you are publishing in these journals, and it's very prestigious to publish in an IEEE journal. At one point of time, I heard one of the IEEE leaders mention that if you are targeting a PhD, one of the essential facts is to publish in a journal, right? So that is the importance of publishing in a journal. And we also have this program called the IEEE Future Directions. I have a slide, one or 2 slides, just in a couple of seconds from now. I wanted to talk about it. And one of the things we have started doing much more significantly today than perhaps more than a decade back is on public policy advocacy, right? So we were seen probably 10, 20 years back just as a purely an engineering professional organization. But definitely from a standards perspective, we see that quite a lot. There is a lot of connect between standardization and doing public policy advocacy. And we are doing that quite a lot. People reach out to us for providing feedback. We make comments where there are opportunity for making public declarations. And I will talk about that also in a few seconds. And people who are publishing patent, it will be good to know that one of the most cited publications when you are doing patent publication is through the IEEE. And we did a study on researching new power patents, and the results are quite there. IEEE dominates on the patent portfolio in autonomous vehicles, Internet of Things. These are the new age technologies that we are talking about. And you might have heard Sophie talk about it in her board of directors series for people who are there. One of the core things that are happening today, and it's referred to in multiple ways, whether you call it Industry 4.0 or digital transformation. And one thing that I wanted to highlight here, so a lot of people talk about digital transformation in the way it is transforming industry, right? And I have identified some of the key technologies that is driving the industry 4.0, whether it is cloud computing, cybersecurity, industrial internet. But also, I think it is not appropriate just to look at digital transformation from an industrial lens. I think digital transformation is happening across the society, right? The way we used to live and work and play, significantly different to what it was and then what it is today. Today, children are coming online. Technology is touching us throughout the day. So in the context of these things, you have to look at how do we build trust in the technologies that we are using? How do we build the appropriate frameworks, the appropriate standards? And how do you ensure that we are progressing technology, but at the same time safeguarding some of the key elements of it, and that is part of the mission that Sanjay ji mentioned in as part of my bio is building trust in technology is one of the foremost aspects. One of the key work, and that I will later allude to in my standards talk, is the work we are doing on children data. So these are things that IEEE is really pushing the boundaries and how we look at things, particularly from the standardization perspective, because we are having young adults, children who are behaving as adults now, right? So my first experience with computer was about in the mid-20s, right? So or early 20s. Nowadays, it's happening at the age of 2 and 3, or probably earlier, right? So things are changing rapidly from that perspective. So, some of you may know about the future directions. There is a committee under the IEEE Board of Directors. It is called Future Directions. And this is my last slide on the IEEE introduction. I think it's a good segue into what we do within the standards. And the IEEE Future Directions looks at, it anticipates the direction of new and emerging technologies and how IEEE can make an impact in that world, right? So if you look at some of the new topics, there is a Future Directions Committee on quantum computing. We just started one on digital reality or metaverse. So the IEEE looks at, okay, what are the technologies that are evolving and what should be the role of IEEE and how we can convene experts together to look at various aspects of these emerging technologies, and also from my perspective personally, how we can play a role in that. So there have been quite a few future directions which have graduated. It's 2 to 3 years, and now the more recent ones that I talked about, right? So and then one thing that I thought I will put it in here because I am addressing students in this particular talk is the role of capacity building and skills development. IEEE has a program through the India office called the Blended Learning Program. It is anytime, anywhere continuous education. It is an immersive learning combined with hands-on labs with adaptive assessments and built on a completely big data analytics and machine learning platform, which provides excellent learner analytics. And there are quite a lot of courses that we are doing ranging from VLSI, Wi-Fi, IoT, software engineering, EMI, EMC, artificial intelligence, and machine learning. So it's we have about 40 to 50 programs around that, and that's kind of important when we talk about technology, because today we are saying blockchain, tomorrow we are saying quantum. So it is impossible to just go back to school and keep studying all these things. So there needs to be a way for professional students to get updated on these technologies as they are going through their regular curriculum or their regular professional life. So it's important to have the capacity building as a very key portfolio when you are going through your daily work. And this slide needs to be updated, but it really reflects on the IEEE Computer Society puts a top 10 technology trends, and you can see that some of the things that we are going to talk about, it is really real today. Like in 2019 we talked about VR, AR, MR, metaverse is quite real today. We are talking about assisted transportation, deep learning. So these are all very, very real today. And sometimes what is interesting is we don't even realize we are interacting with these technologies as we go through our lives, right? Sometimes when I'm talking to a customer contact center or a chat, perhaps or not perhaps 9 out of 10 times I'm talking to a chat bot rather than a human, right? So So in this all this context, it's very important to where it is all grounded, right? So technologies are great, but technology, if you want the technology to evolve, if you want the technology to be adopted across the world, if you want to grow the particular technology, it is driven through standards, and we'll talk about it in the next 70 or 80 minutes. And IEEE is a leading developer of industry standards. So IEEE as a niche, right, we don't focus on service-based standards and things like that, but it is very focused on technology-specific standards or impact of the technology on the society, right? So we have the technical standards and we have the contextual standards also. Of course, needless to say, if I'm doing it in person, typically I do it through a Q&A and I communicate, I converse with the audience, but it is a little bit more challenging to do it on a web audience. But one of the most popular standards is Wi-Fi. In fact, when I give this talk, I talk about, I ask people, are they aware of any IEEE standards? And typically they are not. And it's interesting that they all know Wi-Fi. It is just that they don't know that Wi-Fi has been developed by IEEE and it's under the moniker of IEEE 802.11. That is the numbering, right? So, and similarly with Ethernet, the cables that you use, the 802.3, there are several such standards, FireWire, Zigbee, National Electric Safety Code, and the list is pretty big. So, sometimes we just don't realize, in fact, when we use phones and computers, a lot of the backend, the computer hardware, the chips that are developed, they are built on some of the standards that are built by the IEEE through the Computer Society, through its Design Automation Standards Committee. And we will, demystify all that in a second. So with that overview and with that context of what IEEE is, what we are doing, where we are going with emerging technology, and I will next dovetail into the IEEE Standards Association piece of it. And so when we talk about IEEE SA, we are what we call ourselves as the OU within the larger IEEE. So IEEE has technical activities, it has membership and geographical activities. For example, the Region 10 is part of MGA because it represents the members and their interest in the region. Within the IEEE Standards Organization, we are one such vertical within IEEE, one such operational unit. But what we do not, the difference between the standards working groups and perhaps some of the things that you are familiar with within the sections and the chapters, we don't have chapters of our working groups. And for the simple reason that standards are global. There is no, we don't want to regionalize the standards. However, there are ways and means on how regions can participate in the standards development, and I will talk through that at a later point during this talk. But the whole idea is to advance global technologies and technology platforms. So, so we have one working group, perhaps when we are developing a standard where participants across the world participate. It is a challenge sometimes because the world is not flat. We live in different time zones. It's certainly not easy. But having said that, there is significant participation in all the standards that we do. And sometimes when people propose an idea for a standard, it is proposed by a use case in their backyard, in their region. And then when it becomes a working group, suddenly they realize that the same problems are faced other places. There are people globally who join this particular program and drive that particular initiative. It is about promoting innovation, but at the the fundamental layer, it's about protecting public safety, security, health, and well-being, and more importantly today, contributing to a sustainable future. The strategic focus of the IEEE, we are in an era of geopolitics, so it is to balance the geopolitical portfolio with the emphasis on our vertical industry practices so that we are able to support emerging technologies. And one of the key regions that we are also growing is in Europe, where there is significant importance of this. We look at emerging and critical technologies with a possibility of high impact, for example, sustainability and autonomous technologies, right? And when we look at these emerging areas, we not only look at the technology side, what are the technical aspects, for example, how fast it should be, what should be the power, the latency, all these functional requirements, but we also look at non-functional requirements such as privacy, identity, and and sometimes one of the fundamental standards we develop today is about taxonomy and ontology, right? So people use terms, and when people talk to each other, we want to make sure that we are meaning the same thing when we are using certain phrases. The idea is to grow and sustain our consensus platform. It is developed through a consensus mechanism, and it's a collaboration of experts around the world, people who are peers, partners, competitors, to push the ideas through and come together in developing this work program. And also in this context, and I will mention about it, one of the key programs that we are looking at is how do you look at standardization, which is a more formal way of standards development work through bodies such as IEEE, and also the open source, which is a completely different paradigm, a completely different model. And IEEE has been one of the leaders in bridging this two communities together through a platform that we just launched about a year or two back. Okay, I didn't mention this. Probably I should have moved this slide up front when I talked about it, where we sit within the organizational structure. So I won't go through it again. I didn't realize that I had this chart. And when we develop standards, we always look at market impact, and I talked about one of the most popular standards being Wi-Fi. Significant impact, right? Today, we have about 18 billion devices that are being shipped, 8 billion that is being used, and close to about 3 billion devices that are connected to Wi-Fi that are being shipped every year. If you think about it, it's quite an enormous number. And, I talked about the annual shipments and the cumulative shipments, but it's really important to understand this because we are living in a connected world today. And what is making it possible is to ensure that we have things such as interconnectivity, interoperability that go along with it. When I got into the, when I was started focusing on IoT, several years back, people were throwing numbers such as in 2025, there will be 50 billion connected devices and things like that. And to be honest, when I, way back when I started looking at it, I was a little bit skeptical about it, right? So, and then when I look at these numbers, and sometimes in my experience, I realize that this is probably, probably we are already there. We don't have to wait till 2025. And I prefer to have my talks with certain anecdotal references, right? So I go through, I travel, and we all travel. When we go through an airport, you go through a security screening. And every time I see, what goes through the security screening, the number of devices that people are putting on the belt keeps on increasing. There is a laptop to tablets, multiple phones that we have, a work phone, a personal phone. Today we have devices such as wearables, cameras that are connected. So you can see that just one particular individual is having so many connected devices on him or her, right? So, it's quite amazing how this has really grown. And really, the evolution today, where we are at with the Wi-Fi evolution, it is quite amazing. And I picked Wi-Fi particularly because it is perhaps one of the most used standards with its presence in several technologies, whether we're talking about consumer or factory automation or industrial automation. Wi-Fi is really pushing the boundaries. And it evolved from where we were way back when with the 2 Mbps, and it has had a 1,000-fold increase in throughput. Can you imagine that? It's 2 to 3 orders of magnitude that has increased over that time. And today we are looking at what we call as Wi-Fi 6, which is IEEE 802.11ax, which got published in 2020. And then people are already looking at, so we support the 2.4 and the 5 gigahertz band in some countries. We also support the 6 gigahertz band. And today, as we speak, there is a draft document that is already moving on Wi-Fi 7. So in that context, right, and the Wi-Fi 7, they are talking about another order of increase within between Wi-Fi 6 and Wi-Fi 7, and that is not surprising at all. I'm sure a lot of people, we go through our daily lives, and some people, when I take the metro in the morning to go to work, everybody is on the phone. People are listening to music, people are watching videos, and these videos are not small data. It consumes quite a lot of data. So as you want to, as the individuals start consuming a lot of data, you need to have the appropriate speeds, the appropriate latency. So and the Wi-Fi standard is defining that. One of the interesting things about Wi-Fi also, and it's important to note that, is about the importance that they give to backward compatibility, right? So today you use your phone connects to a router, right? So typically what happens is when a new standards come out, it is the end device, the consumer device, the phone that gets upgraded first. But sometimes you may not get the right throughput if your access point doesn't have the latest technology, but it will still communicate, it will still work, right? So from that context, it doesn't stop from working, but once your access point gets upgraded, then you really get the complete feature set of what the standard provides. In this context, and that is mainly we touch upon that, even though Wi-Fi has a lot of different use cases, whether it is industrial automation or home and building automation or consumer retail. But a lot of times as an individual, we look at more, we experience it through our individual consumer experiences. But the other thing that is significantly growing is what we call as the industrial internet. And this slide was quite a old slide a few years back. And at that time, they said that the industrial internet will touch about 43% of the global economy. And even though the number of devices from the industrial internet will be small, if you look at the annual value by 2025, it is just 3 times that of industrial and consumer internet. So it's a high impact area, high growth area, touching upon different verticals, whether you look at agriculture, transportation, manufacturing, smart cities, and the services that go along with it. So everything is driven through the internet backbone for the industrial application. So it's really growing at a very significant pace. And now when we look at things such as metaverse, digital twin, we have just raised the bar significantly in amount of data we'll consume and what kind of throughput we would require to support some of these technologies and its applications. I was there at Mobile World Congress a few years back, and at that time, one of the big OEMs, they were actually talking about virtual surgery. Can you believe that? Like, probably I will be a little bit skeptical to do that today, but the technology is evolving so fast that it's going to happen, and the implications of virtual surgery are just enormous, right? So then you can really get care any place with experts being anywhere around the world. That's quite amazing. So with all that context of IEEE and where the industry is really heading towards, I thought I will deep dive into the standards part of it. There are a few who are probably working on standards, and perhaps what I'm going to say is perhaps well known. But I just, I'm hoping that this will be useful for the majority of the audience that are listening today. And we will deep dive into the process and governance, which is also equally interesting when we talk about standards. So why do people develop standards? What are standards? So the idea is to develop a set of specifications, establish them, and procedures that are designed essentially to ensure the reliability of materials, products, and methods that we use every day. A lot of times, when we buy a product, you will typically see a mark. I live in India, so I will give an Indian reference, but I'm sure people can see their own reference in their context. In India, we have the Bureau of Indian Standards. So when a product is developed, there is a mark that is published from Bureau of Indian Standards, which says that that product is safe to consume or safe to use, right? So whether we are talking about using a technology or a product, or even things such as food and drugs, right? Similarly, Standards Australia, they have a similar process. So every country has this process whereby they ensure that the particular product is reliable, right? So it's very, very important to ensure the reliability of these materials. And they form the basic building block on establishing consistent protocols. Imagine that, and since I started my talk with the fairly deep overview of Wi-Fi, imagine that if there is no interoperability, if you are stuck in a place where when you buy a phone, you also have to buy the access point. It is just not practical, right? And then imagine that every phone manufacturer produce their own version of the access point, right? So that's just an impossible world. So it is about establishing consistent protocols, which then allows compatibility, interconnectivity, and interoperability. So what that means is you can, we are living in a system of system today, like we are living in a very big macro systems where there are a lot of components to the system, and each of the components need to talk to each other, need to connect with each other. They need to talk a certain language that they understand that allows for interoperability. And that pushes certain things when you have the interoperability, and I will talk to that in a second. And that allows for product development and speed and time to market. The other essential thing that this allows us to do is to make it easier to understand and compare competing products. So when you, as a consumer, if you are going to go to the market and you are looking at features between two particular product and standards, one of them are adhering to the standards, it enables the consumer confidence. But even in an industrial system, when you are putting an RFP to source systems, you typically in your RFP would mention that what are the kind of protocols that you would like your systems to support, so that that when it's guaranteed to do that, and when you integrate it in your macro system, things will work, right? The other key aspect of it is once you have a standard, it drives new markets. It allows for international trade. So classic case of new markets, one of the things that we all use today. I'm sure most of the countries where people are joined from, we have some kind of location-based taxi services. They call using your mobile data, and that is all driven because you have the IoT, the Internet of Things. You have the standards that are defining location services. So you can really interact through your device, be able to book the convenience that you are looking for, and have it delivered at your doorstep, right? So when I was growing up, you need to stand in a queue for everything, whether it is to pay your utility bill or things such as just paying your milkman, right? So today it's that is just gone, everything is happening through the internet. So it has encouraged new markets and international trade. And in that, it really has driven a lot of innovation, the development and implementation of technologies. I think it is the last decade or two has seen an exponential rise in how the technologies are evolving. So I talked about certain aspects of it, and there's perhaps a figurative view of it, but there are a few things that I wanted to highlight that are not there in the previous chart. Is the fact that when we develop standards, one of the key things that it addresses, it reduces market risk, right? So for example, maybe some of you are from the power and energy ecosystem who are attending this particular webinar today. And about 10 to 15 years back, utilities went through a process whereby they were upgrading the utilities and making them smart. The word smart grid became very popular in about between 2005 to 2010, and still the journey is going on, right? So when we talked about smart grids, it was a whole-scale upgrade of systems with the utilities, but utilities are, making sure that they don't want to take the risk. A particular utility might serve about 1 million people that they are servicing, right? So it is not only large people that they have a commitment to, but some of these upgrades will require extremely large investment. So when you are doing that, you want to make sure that the components in the system are developed in a particular fashion that are adhering to certain standards that allows people who are designing these large systems to make confident decisions that where they are confident that the risk to the market is reduced. And of course, in that context, we do improve the reliability. It becomes a vehicle to address regulatory requirements, right? Again, whether it is healthcare or automotive or energy system, you have a regulator that plays a very strong role. The regulator will come in and say that these are the safety requirements that I want the products to adhere to. And when the regulator comes and says that, it needs to be backed up by standards that are developed, which reflects those particular safety requirements. And when you have a standard, one thing that is probably the most important is it allows for better cost efficiency. So what does it do? So you have a specification, you have a standard, that is published. Now anybody around the world can develop applications to that standard and supply to a global supply chain, right? So what that does is essentially it reduces the cost of the product itself. It allows for better cost efficiency, and we have seen this in our daily lives. You buy a new television with a new technology. When LEDs were becoming popular, but today you look at the same television. A few months later, the price has dropped by a few, a significant percentage, right? Similarly with the mobile devices. So what happens is a lot more people now start building products into the market. It increases the competition in the market. So when it increases the competition in the market, it allows for the cost to come down. And one thing that is unique about the IEEE, and I really feel is a very, very important thing, how we are different to other organizations is we provide the entire framework of innovation and standardization when we talk about our full platform. And I'm talking about IEEE in the full context of IEEE, right? So when a new technology is emerging, and that's why I really felt that, activities such as work done in Future Directions Committee, those are all important, because when we have a new technology coming in, the technology goes through various phases. So you have the conceptual phase where people are, kind of debating, talking about it. And at that time, what happens is typically you will see workshops that IEEE does, or you will see some academic conferences. I say academic because typically the research is ahead of the industry curve. So when things become products, perhaps the research was done a few years before that, right? So people start publishing papers, and then you have some early adopters. So you have the conceptual and the pre-competitive phase, where a lot of conferences, workshops, meeting of the minds, debates on how the technology is evolving happens, and people start publishing. And once people start publishing, what happens is you get into between the pre-competitive phase and the competitive R&D phase, there will be early adopters. Some people will say, okay, this is a great work that somebody is doing. Let me, they might have an interesting application in mind that uses the work that has been published. So they will start building products. So there will be some early products. And at that time, you will get into research and study groups. But still, it's a slightly perhaps early when it comes to standardization. But I will talk through that once I finish going through this whole framework. But what happens is then the technology gets a bit popular, the products get popular, more industries, startups get engaged in either developing the end product or supplying to the product developers. So you have either OEMs or in the case of automotive, you'll have the tier 1 suppliers who are developing and designing systems that sit into a bigger system. And that's when committees, working groups come together, standardization, because that is the time people feel that, okay, there are different, perhaps different ways to do this. How do we standardize the platform? so that we can source our microsystems from other players, so that we know that when we buy these systems, they are interoperable. And so we get into the standards domain. And then what happens is now you get into the products that get out in the market based on standards that are developed by IEEE or others. And then when market adoption happens, you have these alliances, consortia, and the industry forums that come together to promote a specific aspect of a particular technology. So IEEE supports this entire phase, from conceptual to pre-competitive to competitive and development and deployment. There are different groups that look at all these different phases. So that is why it's a great place for developing standards, because we can piggyback into our industry experts. We have several significant amount of academic scholars and researchers who are looking into these areas and looking at how the future is evolving. So it's quite an unique platform that we have. So one of the things I wanted to highlight, and I talked about research to product. Perhaps back in the day, when I used to do some engineering, right? So a research to product development life cycle was perhaps 8 to 10 years. So what you would see as a product, the research would have preceded that by close to a decade, if not a decade, right? We are seeing that cycle coming down significantly. It's shrinking, right? In fact, today, researchers, as they are doing research, they are thinking actively about business applications, the use cases, how to monetize, right? So the thing is, things are changing very fast. In fact, we have, I'm sure a lot of you can connect to this. We have several universities who have incubation cells, startup centers, which allow some of the researchers to actually evaluate their ideas into products. So that cycle is coming down really very, very fast. And that is very important in the context of today, where we are talking to young professionals and students. So in the context of where people who are doing research are thinking about products, it is really, really important to also think about how these products will have a global impact. How do you ensure aspects such as security, interoperability, connectivity through standards? So it's very important that as you are evaluating these ideas, as you are going to market with some early innovations, you also start thinking about how this will scale. What are the requirements that are required for it to scale, right? So scalability is very important when you are going out in the global market. So I talked about the fact that we have the research and standards development under one roof. That's a significant benefit. We don't realize it sometimes, but it's very, very important, right? So we have really some top-notch thought leaders and experts. When I say top-notch, it's absolutely top-notch, because if you look at the list of Nobel laureates that has been announced, several of them have been IEEE members in the past, so or even currently today, right? So it's really true to that word of calling it top notch. We also have 45 technical societies and councils within the one family. And this is again a dimension that nobody else has. It's very important to understand this. We talked about several technologies that today IEEE looks at. But if you look at a system today, it is not about just one technology, right? So previously, a mechanical automobile had a few elements to it, but today automotive is more of a computer, several computers with a chassis around it, right? So when you talk about a car, what do we talk about? We talked about advanced materials. We talk about cameras and LiDAR in the case of autonomous driving. We talk about communication technologies, whether we talk about V2V, V2X. We talk about sensors. There are sensors all over the car, right? So whether it is fiber, your seat warmer that has sensors built into it, the positioning of the seat within the car that has sensors built into it, several things, right? It is sensing the environment constantly. It has proximity sensors to understand where the car ahead of you or around you is there. So significant. And then at the back end, you have several computers that are running, processing data, and communicating through each other by a backbone of Ethernet, right? So for people who do not realize, today, one of the significant changes that are happening in the automotive industry is the protocol that automotive industry is using is moving from an existing protocol that has been around for a while into Ethernet-based applications, so 802.3. In fact, one of the significant participants within our 802.3 umbrella is coming from the automotive industry. So that is another aspect that is a unique aspect within IEEE, why some our standards have this experts who we can touch upon from all our societies. Because today, when any topic we talk about, it touches upon different technologies, and we have a society that looks at all these technologies. Of course, in certain cases, these are becoming very challenging problem. That's where we really want to make sure that when we really develop standards in all these cases, we have the representation from all these different perspectives, right? So, and then the other aspect of it, so we talked about the fact that research and development under the same roof, we are talking about the fact that it is touching upon anything that we do today touches upon several technologies. And the last one, in the context of Region 10, it's very important, right? So we have a global participation. We have members around the world. We have within the IEEE standards, we are kind of unique within IEEE, where apart from individual membership, and I will talk about that also in a little bit of detail in a few minutes. We also have corporate membership, where we have members from US, China, Japan, Europe, Korea, India, and several other countries, right? And we have about 40,000 global participants around the world who participate in our standard development activities. So we are not only having a diverse view of technologies, but we are also having a diverse view of different stakeholders, design, manufacturing, but more importantly, policy, right? Policy arms are different within different countries. The policy views are perhaps slightly different. So we have to ensure that when we build the standard and when people build products around the standard, it allows for appropriate knobs to be present, where people can dial the knobs appropriately depending on what is the position of the regulator or the policy, right? To ensure that we are also capturing the regional views when we create a global standard. I think it's very, very critical in the world we live in today, where everything is driven through technology. There is absolutely no country that doesn't use technology. People are thinking about smart cities. People are talking about anytime, anywhere connectivity. In that context, we really have to capture the views of the different regions as we develop these standards. So one of the things you work very hard when we, at least within the foundational technology practice, and my peers and other practices do the same, is when we develop, when we bring on a new standards working group, where we bring in experts to develop a standard, we really look at all these different elements. Do we have the right expertise from the different focus areas, and do we have the right expertise from the different regions, right? So I think that makes our standards all the more powerful and more inclusive. And to touch upon some of the standards that I talked about 802, but there are several other standards that are really having a big market impact. We have about 100 plus standards in the area of smart grid. We have several standards in the area of digital health or e-health. This is about, the IEEE 11073 family is really about how wearables talk to a cloud, which talks to a remote physician. And I think the last 2 years when we went through COVID, this was particularly important challenge, where people did not want to congregate, they didn't want to come to the hospitals, but at the same time be able to get the same kind of care, right? So it's important to maintain that. So some of the technologies that we are developing allow for this remote connectivity from the patient data all the way to the physician, right? And that really was highlighted in the case of medical use case, but also in the e-learning and education, where people had to learn from home, right? So, and then of course I talked about, I touched upon the autonomous vehicles or intelligent vehicles, several standards in that space, and the Internet of Things. So this is just a glimpse of it. In the summary, I will go into some deep dive of some of the key areas that we are working on, which will be hopefully be exciting and interesting for some of you in this audience, and you will come over and start contributing and participating in our work. So, statistics are always interesting. There are about 2,000 plus standards that we have published. I talked about the fact that IEEE has both individual members as well as corporate members. So we have about 430 plus corporate members. And the next two statistics are very important, So I wanted to just spend a couple of seconds in trying to demystify that. So we have 7,500 individual members, but we have 34,000 global participants. So what does that mean, right? So within IEEE to participate and to participate in an individual standard, right? To participate in an individual standard, apart from the leadership of the working group, which is typically the chair, vice chair, secretary, and perhaps if they manage money, the treasurer, the other participants in the working group, to be able to participate in the working group, they don't have to be, they don't need any form of affiliation with the IEEE, right? They don't need to be IEEE members, or they don't need to be IEEE standards members. They can come and contribute. But having said that, if you want to have a formal voice as the draft standard is developed and it goes for vote, if you want to have that formal voice, then you need to be an IEEE SA individual standards member. So a lot of our community, they are just very interested in developing and furthering the work based on their interest. So they come and participate. So that is the 34,000 or 40,000 global participants we have around the world. But then people who take a formal position in the work of these standards are represented to the individual members. The other important thing is the global agreements that we have with the IEEE Standards Association. One of the key points that we have to recognize, we are a very bottom-up organizations. That means that a working group comes together with individuals or as entities as members, and I will talk through that, what I mean by those, but just bear with me for a couple of seconds. But at the same time, we also recognize the importance of top-down organizations. For example, the importance of the ministry in your own country, so they have certain requirements. They drive policy, they drive regulatory requirements. So what we do is, how do we engage with some of these larger, broader organizations? And this is a way to also capture some of their views within our standards development ecosystem. So we do a lot of global agreements around the world. The agreements ranges from a general cooperation agreement or a memorandum of understanding, or in some cases a much deeper agreement through a standards adoption, where countries are able to adopt the standards that we have developed. And I will explain that in a couple of slides that are coming up. So we have about, this slide is probably a little bit old. Probably we have about 200 agreements globally today, or 200 plus. We have a strong, so these are all, so how do we, how does one engage with the IEEE standards? A lot of times people feel that, okay, it has to be a standards working group. But very many people are very surprised at the number of platforms we have, where there are different ways to engage with the IEEE Standards Association. We offer a portfolio of programs. Of course, our bread and butter is standards development. That is the heart, the engine, if I can call that. But there are several pieces that go along with the standards development piece that I want to talk about, right? So, and I will touch upon, probably I will not touch upon everything, but I will touch upon a few key things. So we have a platform called the Industry Connections Program, and it's and I think I have a slide each for each of them. So I will just give you a very brief overview, and when I talk through the slides, I will mention in a bit more detail. The Industry Connections platform is basically exploring and incubating new technologies and its use. So the future directions really looking at really futuristic ideas, bringing the researchers together. But the industry connections is where products are getting out, and here you really want to do a landscaping of the standards, right? So sometimes it's too expensive to develop a standard. It takes a lot of time, money, effort. So you want to really bring a community together to understand what standards need to be developed and what we need to do. So it's incubating these new technologies and particularly its use, right? We talked about standardization and membership, and I will go through its details in a minute. But we also, so the industry connection program is at the front end of the standards development. So you can bring people together, they kind of debate what we need to develop as standards, and then some of it will filter through as opportunities or an idea to develop a standard, and we go through the standards development process and we develop a standard. So standard development process itself is voluntary in nature, like, how you join IEEE as a volunteer. So it's a voluntary participation. Similarly, standard development is also voluntary in nature. And adoption of the standard by the market is also voluntary in nature, right? So there is no regulatory framework today that shows that that says that your mobile phone should implement the Wi-Fi standard IEEE 802.11, right? It is market that is driving that, right? Of course, when it comes to conformity and assessment and certification, majority of it is run by the market, but in certain cases, perhaps in the energy sector, in the medical sector, so you have the unregulated sector and you have some deeply regulated sectors, where things touch several people, right? So in a serious way. So in those cases, the regulator comes in and they will say that we want a product to adhere to certain safety standards that are published by IEEE or others, right? So in that context, what happens is once the regulator says, I want the standard I want your product to adhere to this particular standard, then there is an environment that needs to be created that ensures that we are able to test those products to those standards, and that is really where conformity assessment and certification come in, right? So where we certify that the product is actually meeting the criteria that is established in the standard. I mentioned the fact that we published a platform that is bridging our standards development, traditional standards development activity and our open source community. We have the IEEE SA open source platform. There are then other products that we have, the alliance management services, the registries. This is very interesting. This is similar to the Wi-Fi story. Everybody uses the MAC address on their devices, but very few of you know that these MAC addresses are actually administered by the IEEE Standards Association. So if you're forming a new company, you want to get a block of MAC IDs, then typically you would you would reach out to the IEEE SA to get that block. And then we have the industry affiliate network. I will talk about it when I go through the slides. And finally, the work on the policy engagement, where we are doing, where we have established several new programs. I talked about the 180 agreements, but we also have this government engagement program and standards and the fellowship program that we do. And I will go through it when we talk through that. So now I would like to just spend a minute or so in each of these programs. And I'm just trying to do a time check here. We are probably on the hour mark. Maybe what I will do is I will finish this set of slides in about 10 minutes, and maybe we can take a 5-minute break. I will let Sanjay Kar, I will come back to Sanjay Chaudhary after this to get his views, and we can go from there. So let me go through the portfolio of programs at this point. The Industry Connections program, we have about 60 programs. It ranges from AI, blockchain, big data, digital inclusion. When we talk about digital inclusion, there are some very interesting work. Agency of data, I'm sure a lot of you around the water cooler or your coffee rooms have talked about who owns my data, right? When you are using your phone, there are several providers in that supply chain, right? You have the phone manufacturer, you have the cloud service provider, you go through various systems. So when the data is being put, who has agency of data, who has ownership of data? Very complex problems that we are looking at. And what typically these Industry Connections program do is they develop a roadmap, standards roadmap. So it talks about how the standards will evolve in this particular technology space. Then out of that, we will also establish some proposals for new standards. One of the things that they do as they develop the standards roadmap are trying to understand the view of the experts is to bring experts together through workshops and events and publish white papers, right? So these are not a typical peer-reviewed paper that you publish through a conference or a journal. These are the papers that are produced within the working group and published as white papers. And then sometimes they develop database and registries, right? And they have some of the things that I mentioned here are just a few of our 60 programs. You can go online and check the whole range of the 60 programs, but we have programs around children's online safety. We are looking at a very interesting program called Meta Issues in Cybersecurity. This is actually driven by experts predominantly from Australia, where we are looking at how we can really, cybersecurity has been looked at for several decades now, right? So when I was doing, I was working on design automation and as part of the semiconductor sector, we were looking at cybersecurity. But as the technology is evolving, we see that the number of cybersecurity attacks is only increasing. So as we address from a vertical perspective, from a bottom-up perspective, how can we really look at what are the major challenges and should we rethink how cybersecurity needs to be addressed? So people are really looking at those aspects within this particular community. And there is a link that I have provided, which provides you information on all the activities. It really is a safe harbor environment, which precedes the standards development process, which talks about how do you come together and develop these activities. It requires fairly minimal effort. It follows the IEEE principles of respect and neutrality, and it's quite an efficient path towards producing a standard or a publication through the IEEE. And there are several programs, and I won't go through that, but I just wanted to keep that in this deck so that people have a look at some of these programs. One thing, however, I would like to mention is all our working groups, whether it's a pre-standards working group or a standards working group, they are governed by what we call as policies and procedures, because we have to be very clear when it comes to rules of engagement, right? Particularly when it comes to standards development, it is extremely watertight, right? Because we have industries who come together. These industries might be partners. Sometimes these industries are competitors. So you have to establish a very, very clean framework on how these individuals or entities participate and come together and participate, right? So, and I thought I will have a form, and the slide deck will be circulated on how you really start an activity within the industry connection program. And typically our working groups on the standard side is 4 years. On the pre-standard side, it's 2 years, right? And there is a process that we go through, that you have to fill out a form and you submit the form. The form is reviewed by experts within the industry connections committee, and then they make some appropriate recommendations back to the people who proposed that, or if they approve it, they make a proposal recommendation to the standards board to get approved, right? So now I want to touch upon standards, right? So I mentioned about the fact that we have about 2,100 standards, so that was about the pre-standardization. Now we have, I mentioned about the fact that we have several participants and we have several individual members. But one thing that I wanted to touch upon here is the fact that there are 2 ways to develop standards within the IEEE. You can come together as individuals or you can come together as industries, okay? So there is sometimes confusion within our community, perhaps a valid confusion. So when they become a corporate member of the IEEE Standards Association, this has nothing to do with the access to the digital library. I want to be clear here. You want to become a corporate member of the IEEE Standards Association only if you have an interest in developing or contributing to a standards development effort, right? So when you propose a particular standard, what happens is the proposer can decide whether he or she wants the participants within the working group to represent themselves, not their entities. So they are individuals, the way you represent yourselves within an IEEE section or within an IEEE chapter, where you are representing yourself, or you want to be represented through your corporate, so the proposer can make the decision whether it's an individual based standard or an entity based standard. And once the decision is made and the standard is approved, then what happens is the recognition of the members within the working group happens through the same way, right? So then we either recognize the individuals as members of the working group or we recognize entities. So in the case of entity-based standards, you can have any number of people from a particular entity join the working group, but ultimately it is one entity, one vote, right? Independent of the size of the entity. You can be a government institution, you can be a startup, you can be an academic institution, you can be a large corporate, you can be a regulator, but everybody gets the same vote. And there is a cost to become a corporate member of the IEEE Standards Association, right? So in the individual process, they represent themselves, each individual, and typically it requires a minimum of 10 people to form the group, to form the ballot group. In the case of entities, it typically requires about 3 committed entities. I typically, when I work with the standard committees, I go for 5 because we live in an age of where industries are merging together. There are, industries are getting bought out. So we want to make sure that we don't fall below the quorum, right? So, and that process is driven by the kind of membership that you will have. So for example, if you are participating in an individual member and you want to ballot and you want to have formal opinion on that standard, then you become an individual member. But if you want to have, if you are participating in an entity-based standard and you want to have your views heard in that standards development process, and you want to actively contribute to that standards development process, then you have to become an entity member. More recently, there was a very important change that IEEE Standards Association did when it came to membership. The fact that they meant, if you are not an entity member of the IEEE Standards Association, you can still join the working group and you can actually observe the standards development effort. This was not the case 2 years back. This is a case that happened perhaps over the last year, where entities can participate and observe. But if you want to have an active contribution, then you need to really be an entity member. I talked about I gave an overview of the conformity assessment. The idea here is as we develop a standard, how do you ensure that the standard, when products are coming into the market, the products are adhering to that particular standard. This is very, very critical, right? When people are developing products, they have to understand the role that standards plays and how we can validate and verify the use of those standards. So IEEE has a program called the Conformity Assessment Program. It's called ICAP, IEEE Conformity Assessment Program, whereby we provide oversight for the testing and certification that allows for consumers of those products an increased confidence. One thing that I want to highlight here is IEEE Standards Association is not, we do not do the testing. So we are not a lab. We only issue the certificate. So that is truly, we are a third-party certificate issuance agency. We are neither a developer of the product or a consumer of the product. We are a third party, and the testing is done by an external lab. The lab generates the reports and it sends the reports to the IEEE, and then the IEEE verifies and validates the report and issues the certificate to the manufacturer. And there is a process that we go through when we onboard a lab to test to the products. So there is a test, lab assessment, and authorization that goes through. And there are several examples where we have standards, certification that are going on, quite a lot that's happening in the energy space. And the benefit of doing that is it's provide manufacturers a proven method for demonstrating compliance to that particular standard. So when we are talking about go to market, right? One of the ways people try to go to market is to make sure that they are differentiating their product from the other products that are out there in the market that are trying to address the same requirements, right? So how do you differentiate yourself, right? So by having a conformity assessment and a certification and a certificate from the IEEE, it allows those manufacturers to demonstrate compliance and thereby increase the confidence and reachability to the market. It also allows the end user to make better decisions and for market acceptance, as I mentioned just now. So today there are some areas where there is one area that we touched upon, and in the energy sector where we started developing a certification program, and it's incredible that when people were deploying products before we had the certification program, when the regulator went and did the testing, even though the manufacturers said that they were compliant, 8 out of the 10 products were non-compliant, even though they were claiming compatibility to a particular IEEE standard. So what now they have done is they have invested to provide a formal compliance program where these technologies will actually go through an actual testing and verification. So it is not only trust that you have in the system, but actually have a formal process to verify those products. And of course, we talk about the fact that the value brings in credibility. It's a full spectrum service that the IEEE provides. When we talk about the full spectrum service, we are talking about industrial products. So when we talk about always industrial products, people who have been participating in working groups, they understand the importance of it, because there are aspects around legal stuff. So this particular program provides the legal and the operational umbrella for testing and the conformity assessment, right? So the IEEE SA open. So what has happened is now one of the things as technologies are getting complex, we see a lot of our standards addressing reference framework, reference architecture. So what do we mean by a reference architecture? A reference architecture is not actually an implementable architecture, right? It is the first fundamental architecture that people develop. And then what they do is, once you will see a reference architecture for IoT, you will see a reference architecture for smart cities. So that is the underlying framework under which things will be built. And then what people will do is they will use that reference architecture, and then they will now bring in products. Hang on, are people able to hear me? So I just want to make sure. I just heard Sanjay. Can you just check if you are able to hear me? Okay, thank you. So I just heard that I myself left the meeting, so I got a bit surprised. So what happens is when people are developing this reference architecture, then what we do is they will contextualize this architecture. They will say, okay, I have a IoT reference architecture. How can I build a reference architecture of a transportation IoT or a medical IoT, right? So then they derive from the reference architectures. And one of the things that goes hand in hand with that is some of this implementation happens within the open source platform, right? So that is one way where people are looking at a standard and building a reference implementation of that particular architecture within an open source context, right? So that is one way. Sometimes what happens is when we were developing design automation standards, people who are from the semiconductor industry, they would know about a particular standard called VHDL, right? So when we have that particular standard, we started developing test cases that test to that standard, and they publish the test cases as open source, right? So we have in Verilog A, Verilog MS, where people are developing the specification, and then people are producing testing to the specification in open source format. And what that allows is when I am, let's say, purchasing a simulator, right? And I want, if the simulator claims that they are adhering to the particular standard, how the simulator is built, then what I can do is I can take this open source test cases and run those suite of test cases against the simulator and actually confirm that particular product is meeting the requirements that are set in the standard. So we are seeing that a lot of different ways where open source is being used in the context of standards, and they were really being developed as two separate communities. Now in 2021 or maybe 2020, we published a platform called the IEEE SA Open, where we really are bringing together a open source development platform, combining both the power of open source development tools along with the member network that we have. And I'm sure a lot of students and young professionals who are here, they might be involved in different open source projects. In fact, the IEEE SA open platform, it allows for other communities to come and start their projects within this platform. It doesn't have to be focused around standards. So you can see that the number of groups and users that we have today on that particular platform. We have what we call as alliance management services. Probably this is a little bit too deep for an introductory standards overview, but I just wanted to just give it 10 seconds on it. One of the key services that IEEE SA provides, you might have heard about a lot of alliances that get formed. People call it sometimes alliances, sometimes it's called consortia, where industries come together and form most of the time a market-driven activity, right? Now, in some cases, for example, MIPI, and or a wireless power consortium, in some of these alliances, particularly in the case of MIPI, the alliances also develop standards. Typically they don't call it standards; they call it specifications, which is developed by industries coming together. It's not a fully open platform. It's a group of few industries coming together and develop a specification. And sometimes these alliances feel that they want some organization to run the services for these consortia. So we have an alliance management services where we provide the backend infrastructure for people to run these alliances. And one of the interesting things that have come is how to convert, is there a path for people who are developing specifications within the alliances and bring it out as an IEEE standard, and I will talk about it in a second. I mentioned the registries, where IDs are involved, MAC addresses, right? So IEEE provide MAC addresses at large. We have a lot of manufacturer IDs that we provide on the healthcare space. We provide IDs on the ether type values. So there are different types of IDs that we provide to manufacturers, and that is driven by the registries. Then we have the industry affiliate network. So a couple of slides back, I talked about the alliance management services, where we provide services to the alliances. So now these consortia and alliances can develop specifications, right? So when they start developing specification within the consortia, it is a closed group, and sometimes the consortia decides that they want to take the specification more globally. And one of the opportunities that they have through this industry affiliate network program, it is sort of a fast track program where a specification has been built through a limited consensus within the consortia. Then they can go through a process through the industry affiliate network where they can publish that particular specification as a IEEE standard. I've listed a few consortia who have used this model where the specification is developed initially within that particular consortia, and then they go through the IEEE SA process and they publish as an IEEE standard. Training and development is quite important. Here, I'm not talking about training of the technology itself, but training through our processes, understanding our navigating to the IEEE policies and procedures, because a lot of times when people are new to the standardization, they can easily get lost, they can get confused. So we have created a fairly intense training program on, especially for our leadership to take as they start driving new work, new activities, right? So this provides an overview of the understanding the culture, navigating the policies and procedures, and making sure that they are able to work with the community and develop, produce effective documents, right? So policy engagement, and I think this is the last part of the overview. Few years back, we realized that as we are developing standards, we also have a role to play in the global discussions where the discussions around intersection of technology, standards, policy, and regulation. This is really very, very coupled. These conversations are getting increasingly complex, and regulators and policymakers often reach out to organizations such as IEEE, which has a lot of expertise in those technologies and develop standards around those technologies, to work with them, to collaborate with them, to provide feedback, and ensure that we are able to work with these policymakers. So the idea here is to helping policymakers, government officials, and national standard bodies to stay current of the latest development that's happening within the IEEE. And you will see quite an array of bodies that we work with: UNESCO, the NIST within the US, the Internet Governance Forum. We work quite closely with OECD. We have provided a lot of feedback and comment on some of the documents that they have developed. The Europeans have the multi-stakeholder platform. So we work very closely with the European multi-stakeholder platform from the IEEE standards perspective to ensure that the work that they are doing and the work we are doing, we are able to communicate and provide our views and feedback to that overall body of work. As part of that, we have installed a program called Government Engagement Program on Standards. This is really a way for government entities to become observing members of our process, be part of the IEEE standards board. So this allows government officials from around the world to gain a very strategic insights, because these are the people, perhaps they are from the ministry trying to make some decisions on behalf of the ministry on a particular technology topic. And we thought that it's very important for some of these people to be actually part of our process, to understand what are the discussions that are happening within the IEEE and be able to contribute to the discussion, bringing their viewpoints from a regional perspective, perhaps, so that when we produce a document, we can capture these perspectives, making sure that the standard is able to address some of these needs, right? And one thing that I wanted to highlight here is we have about 54 participants from about 37 countries. There are quite a large population participants from the Asia Pacific region. I would say that about 12 to 15 participants, are represented from the Asia Pacific region in this particular program. And then we have a fellowship program, and this is a fellowship program that are mainly addressed towards other standards development bodies with whom we collaborate. The idea here is, I mentioned that we are a very bottom-up organization where it is either people come together as individuals or people come together as entities. And this is quite different to how other standards bodies operate, particularly if you look at some of the European standards bodies, they operate on a one country, one vote. So if you go to an ISO or an IEC, the members are countries, India, China, Japan, Korea, Australia, all these are the members, right? And then they have experts within their own particular contingent, right? So it is important for us when we work with some of these other institutions, whether it is from the ministry or other standards bodies, they understand what is the process of developing standards within the IEEE. So we do have a fellowship program that allows for our colleagues from other national and regional standards bodies or government ministries to be part of this program. Today we have trained about close to about 80 professionals from about 40 plus organizations through the IEEE process. So I will take a pause here. I wanted to make sure that I get a pulse from the group here. So at this point, if I can request Sanjay, should I continue or should I take a 2-minute break? I'm happy to continue. My talk may be last for another 30 minutes or so. And then maybe, what is it? Maybe I will wrap it up in another 15 minutes, and then we will have about 20 minutes for Q&A. Is that okay, Sanjay, that we continue? I'm not hearing any feedback.
I think, Sri, you can continue.
All right. Continue. Okay.
Yeah, please continue. Yeah. Thank
Okay.
you.
Yeah, I was not hearing anything, so I wasn't sure. I thought that I had lost my speaker at my end. All right, so I will continue, and I will try to wrap this up in the next 15 minutes so that it gives some good time for discussions of this. Okay. So, so what happens is, how do you, when sometimes people feel that the process is very complex to participate in standards, and I just wanted to demystify that, particularly within IEEE, it's a very straightforward view to come and participate in our standards development activities. There are, of course, like everywhere in IEEE, we have several committees which look at several aspects within the process. So you have the Standards Association. We are our leadership is the IEEE Board of Governors, and within the Standards Board, we have several committees which look at different aspects of standards development. Standards development, the policies and procedures are extremely watertight, as I mentioned earlier. So we have to make sure that we have good policies that we follow when people come together, because there is a play of IP that people contribute their IP into the standards development framework. There is a process around it. So we have a patent committee which provides the oversight on how the use of patents are used within standards. Very interesting topic. How do we review new proposals? How you make sure that when the work is done by the working group, how do you review on the other side of the gating out process, and then other oversight committees. So there are several committees, and the development of standard is really a collaboration between IEEE Standards Association, which is managing the process on how we develop the standards, and the experts, which is coming from our technical activities. For example, one example is the IEEE 802. There is a standards committee called the Landman Standards Committee under the IEEE Computer Society. So the standards committee sits under the technical activities. The governance sits under the IEEE Standards Association, and that's how that process works, right? So it is really these two groups coming together. One is focused on the standards work, another one is focused on the standards process. And typically within the societies, you will see a standards committee within a society. So the IEEE Computer Society will have one or many standards committees. Sometimes based on technology areas, they will have several standards committees. For example, within the computer society, they have a design automation standards committee, they have an AI standards committee. So they have several such committees. And within the several committees, they support the working groups, the study groups, and other administrative aspects of it. So if you have an idea, where should you go, right? So, what should you do? There is a process that we have, and I've created a link which provides a fairly detailed view of it. So once you have an idea, what we do is there is a form, a template that is there. It is called the project authorization request. It is a fairly straightforward, common sense form. The key elements, without going into the details of the form, is the form kind of asks you what is the problem you are trying to solve, why that problem needs to be solved, and what is the purpose of it, and who are your stakeholders who are coming together, and are there any other related work that is happening in this particular area, right? So there might be some complementary work, and your standard might differentiate from the other work, but will be complement to it. So these are the things that are reviewed by the standards committee. When you fill that form, you send that form to a standards committee, and the standards committee will take a look at that particular form, have few rounds of conversation, because the standards committee is made of experts from that particular domain, right? So, and once they are happy that there is an opportunity to develop a standard, then the standards committee provides that approval. And once that approval is provided, they make that approval to the standards board, and the standards board says, okay, we will initiate this particular working group. Once the working group is initiated, they have about 4 years to develop that particular work. So they will go through their own internal voting. The working group has to develop the draft standard. The working group has to accept the draft standard. Once the working group accepts the draft standards, then we create the formal balloting. So this is particularly important, because what happens is you have members of the working group, but you have a larger community who are interested within that particular scope of work, right? Who probably are not able to participate in that particular working group. So when it goes for a ballot and public review, this is an opportunity where others who are not able to participate for various reasons, they have an opportunity to provide their feedback into that particular standard. And then all the feedback is reviewed by the working group, and then they might revise the standard based on the feedback. And then it's resubmitted back to the standards board for approval, and then published. Once a standard is published, the standards committee, the standard is valid for a period of 10 years. Within the 10 years, or at the end of the 10 years, the standards committee has to come and indicate that the standard is still current. People are using it, it's still valid. It is called affirmation, where they say that, okay, the standard is still good. Or if there is no feedback that we get from the standards committee or the working group, then we put it on our withdrawn status and we archive that particular standard. So I talked about the project authorization request, where you fill that form and you send it to a standards committee. And then once the standards committee has reviewed that, they will send it to the new standards group within the IEEE standards board, where they will review it and approve that particular PAR, as we call it. Once the PAR is approved, then the working group proposer is allowed to create a working group and establish the work on that particular standard. Our participation is direct participation. Anybody can come into the IEEE process, show their interest and say that they want to be included as part of the process. Every working group has a policies and procedures document that is publicly available. We have a concept of broad consensus. So where, it's not about every participant having to agree. It's not 100% acceptance. There is formulas around it, but some of our key standards, such as Wi-Fi and all, they expect their consensus to be at 92% or something like that. So they expect a very high degree of consensus. The Standards Association governance itself has a baseline for it, below which you cannot do, but a lot of standards working group go beyond that baseline on what they mean by consensus. We look for balance. Balance means that we look at both geographical representation, but also stakeholder representation, where we look for representatives from the design, manufacturing, government bodies, all the different perspectives to come together. And all our work is transparent, so you can always go to the working group and the minutes are recorded. It will be available in a repository that is maintained by that particular working group. Who can participate? Really, anybody can participate, whether it is any individual, whether they represent industry, academia, consumers, research organizations, consultants. It is really an open form of membership, any industry, any size, right? So, and as I indicated, you don't need to be a member of the IEEE or the IEEE Standards Association also to participate. One of the things that I wanted to mention here is when IEEE publishes document, we develop different types of document. I will probably touch upon the first three. So when we say IEEE standard on something, that means that the document has mandatory requirements, typically qualified by the keyword shall. Sometimes we make recommended practices where we say that, okay, this is what we are recommending. This is the view of the working group, but the implementers can decide to use it or not. And when you talk about a guide, it is just a best practice. We don't make any recommendations at all. We just provide alternate options, and people can choose an option based on the parameters that they are working under. And the National Standards Adoption Program is really one of the things that we implemented about 10 years back. We have several adoption programs within the Asia Pacific region. We have agreements with different types of agreements. We have an adoption program with India and Australia. We have cooperation agreements with entities in Korea, with entities in China and Japan. So it is pretty broad. And the standards adoption program really helps in ensuring that a consensus has been built through IEEE when they developed a particular document, right? So when there is an interest for a region to develop a standard in a particular area, and they feel that IEEE has already developed a standard around it, then through the adoption program, they can adopt the standard and they can publish it as a regional standard within their own region. And as part of the adoption process, they can also do a direct adoption with no changes, or they can also do a country-specific changes within the standard, because sometimes there might be some subtle changes that might be required. But for the country-specific changes, there's a process in which you do it, because we want to make sure that it doesn't break any interoperability. We don't allow all our standards to be available for country-specific changes. For example, the Wi-Fi. You really don't want a country-specific change when you are adopting IEEE 802.11, right? So the countries may seek to adopt IEEE standards for different reasons, because they might be having a standard that is being referenced in their regulation. And sometimes when they are referencing standards in the regulation, they prefer to refer their own standards. So as part of the adoption process, they can adopt this particular standard, make it the regional standard, and then reference it. And as I said, there might be some differences they want to establish between the work that we have developed, so they can adopt and address those differences or address the portfolio gap. So in the next few minutes, I will just summarize where we are and highlight some of our key programs. I think it's very important to understand what we are looking at today, apart from just looking at technology and the technology aspects of it. In the introduction, you heard Sanjay Chaudhary indicate that I manage the foundational technology practice within the IEEE Standards Association that is focused around certain foundational elements, quantum, blockchain, and all the verticals, the horizontals, which is industry agnostic. And then I have my peers who look at different aspects of this. We have healthcare and life sciences vertical, mobility vertical, energy. Recently, we started a sustainability vertical just in 2023. Then we have a telecom and connectivity vertical. And when we talk about the practices is much larger than just looking inwardly within IEEE. The practices typically look at who is doing what around the world, where do we engage in policy, where do we engage with other national standards bodies, how do we engage in the region, how do we collaborate with other experts. So it's a complete framework, and then try to understand how can we further technologies within these particular focus of that particular practice. And I've highlighted each of the practices has about 3 core focus areas, and I don't want to go through each of them, but you can take a look at that. Couple of years back, IEEE 802 celebrated the their 40th anniversary, right? So I talked about the evolution of 802. And here I wanted to give an example of some of these work that is really shaping the future of both the industry and the society. So of course, the underlying to all that is IEEE 802, which is addressing a range of 5G applications. So when people talk about 5G, sometimes they might be talking about the 5G protocol itself, which is developed by ETSI, but there are a lot of 5G applications where IEEE 802 standards are able to address these 5G applications. So we have to understand that, whether we are talking about dense urban or indoor hotspots, these are some of the use cases that are actually addressed by the 802 technologies, by the array of 802 technologies. You have the 802.11ax, which is the Wi-Fi 6, and then you have the .11ay, which is on the millimeter wave, like 60 gigahertz and above. And then we have a work on sub-gigahertz, which is on AH. And this is a old slide. I think these projects have also progressed. We talked about digital transformation. It's sometimes very unclear what we mean by digital transformation, but we know that every industry is going through digital transformation. But within IEEE, when we look at digital transformation, it is at the forefront of every organizational strategy. It is really the adoption of digital technology to transform their services, right? The business that they are doing by replacing non-digital or manual process through digital process, right? And the implementation of digital transformation really needs reliable infrastructure, sustainable architecture, and very, very important. And that is one of the core focus of what I'm trying to do is really trustworthy and secure platform. Security is one of the fundamental areas where people have been looking at it in certain ways, but I think we need to rethink how it is done. But the idea is to make sure that IEEE is a trusted platform where we are being able to provide globally accepted and time-tested standards, right? The other aspect that we are looking at is the use of AI. I think needless to say to this audience, we are using AI everywhere. They are saying that by 2024, it'll surpass the $500 billion mark. That's just a staggering number. But what surprised me really in this whole chart was when I looked at it first, when I asked my peer to provide me some information, was the fact that there are 77 million adults who are using some form of AI assistant in their cars at least once a month. That's just that's a staggering number. But along with it comes several challenges, whether the challenge comes in the form of transparency, algorithmic bias, governance, the AI governance model, the accountability. So there are several challenges that come along with it, right? So, and these are real challenges, and these challenges are quite unpredictable. So in the context of it, IEEE has put significant effort in developing what we call as ethically aligned design. So this work started way back when people were not really looking at it at all how do you look at the impact of AI and contextualize it, right? So we looked at a document where we put a group together. It was our pre-standards group, which was looking at how do you look at it from principles to practice? And they produced this document, which is available for free, called Ethically Aligned Design. And they went through a process and they did several workshops around the world, I think 3 or 4 in the Asia Pac region, where they gathered the feedback from their initial document, which they incorporated that in their version 2, and they published their first edition in 2019. So based on that pre-standards work, it gave rise to several standards work. We have what we call as the IEEE 7000 series of standards, where we are looking at a process for addressing ethical concerns at the stage of system design. And there's a certification work that goes hand in hand along with that. Then looking at transparency, the data privacy process, algorithmic bias. So each of the issues that I highlighted, there is a work that experts are coming together and developing standardization. And there are some really interesting work where there are people talking about a standard for machine readable personal privacy terms, right? So we use several applications today. We download the applications, we accept without even reading the privacy terms. So how can we make sure that these privacy terms are actually machine readable? And then there is a way to interact with an application, setting what your care abouts are, and the machine is able to read the privacy terms and able to match with your care-abouts, right? So very interesting work happening there. We talked about metaverse, so now we are looking at the same way how AI is making an impact and there are challenges around AI. Similar things are happening around extended reality. And there was a recent document that was published by the IEEE pre-standards work on extended reality and the erosion of anonymity and privacy. Very interesting document is available through the IEEE SA platform. And I talked about certification that goes hand in hand with our AI process. So we just recently launched a program for certification of AI. So you can see a play on words there on certified, where the AI and E are capitalized AI expertise. So we really, and this certification is slightly different to product certification. When it comes to things like renewable energy, AI systems, there are millions of systems around the world. It is practically impossible for IEEE to go and validate each of these systems to come for compliance. So what we are developing is we are developing a pool of assessors around the world. So this certification is really where people come together, get certified within our process, within the framework. And at that point of time, they represent IEEE as assessors, where they will go and assess systems, right? So it is similar to the ISO 9000 framework, where they have a pool of assessors around the world who go and validate the systems. It is very, very similar to that. So we have launched this program where we are creating the set of assessors to ensure that we are building trust and responsible innovation in the systems that are being focused around AI. So just to conclude, it is not only the focus around technology aspects of it, but also the social impact. So we talked about ethical AI systems. I touched upon the agency of data, how we do data governance, but we also have some interesting work on children online rights, and that is really next generation challenges we are facing today. Children are behaving as adults. With COVID, that has also accelerated it. So there are a lot of work that is focused around within the IEEE, which is focused around the children, and how do we ensure responsible behavior from product manufacturers where the products are targeted towards children. So I will refer to that in a minute. And then I talked about the fact that we are building trust. One of the frameworks we have is what we call as the TIPS framework, where we look at trust, identity, privacy, protection, security, and safety. So when we are looking at new technologies, one of the things I work with experts as the technology is evolving is to see how these challenges are being addressed within the standards framework. Are we addressing, should we put a group together to address these particular challenges? And this is what we call as the non-functional requirements. So it doesn't really affect the functionality of the product, but this is becoming really, really critical as the technology is touching the last human being. So, today you will see a lot of organizations around the world, regulators, ministries talking about data privacy, making regulatory rules, where should the financial data reside should it reside within the country? So a lot of these things are coming up. So within IEEE, how do we address these aspects, right? And I talked about the trustworthiness, the fact that we are working on focused around children. How can we make sure that children really have a space to grow up and learn and be able to use technology, where we are addressing some of the serious risks that are related to privacy, safety, and security. And I'm sure a lot of you have heard quite a lot about it. The fact is that the physical and mental well-being of the children needs to be addressed. People are constantly in front of monitors. Probably a lot of people are hooked on to online gaming. There is a lot of harassment that happens on online gaming. So a lot of very, very challenging things that are happening enabled through the technologies that we are developing. So as we are moving the technologies forward, how are we addressing these other social critical issues? There is quite an array of work we are doing when it comes to children online work, and some very interesting workshops and case studies that we have published. And recently we published a standard called 2089, which is the age-appropriate digital services framework, and we collaborated with an organization in the UK called the Fire Rights Principles. And then a derivative work out of that is 2089.1, which is for online age verification. Very, very interesting work that's happening. There is a standards as a focus dedicated web pages for cyber security and smart cities. So you can take a look at it. I put placeholders for there because there are several standards that are being addressed within this framework. I prefer that you take a look at it. I provided the link for you to address, and then really this is all brings this together. Why should students learn about standards, right? Everybody uses standards in his or her professional life. Most aspects of business, I don't want to say most, I think today every aspect of business, whether you are talking about standards in the financial sector or in the technology sector or in the overall governance, they are all impacted by standards. And in the curriculum, typically this is not addressed, so they have very little to no exposure to standards. But at the same time, when you take a job in the industry, the first thing that probably that you will be working on is on products that are using standards, right? So the industry puts a fair amount of effort in training students to do that. So, all the companies will provide on-the-job training. So really, if there is a student who comes with the knowledge of standards, companies take that very seriously. And this is not just for engineering students. A lot of times we think that it is just for engineering students, but in the world we are living in, particularly I talked about the A and ethics, XR, metaverse. Here we are really talking about certain aspects, the societal aspects, which is not driven just where this information is just not useful for the engineering students, but it's applicable to people who are focused on business, law, economics, political science, public policy students, right? So standards are making a key play in all these disciplines, and it's very important for these disciplines to have a fairly good understanding and exposure to standards. And how can it benefit students, right? So participation in standard development is very key for growing technology leadership within an organization itself. Organization differentiates itself. There is an aspect of being present in a global forum, and that establishes success to the organization, but also contributing and participating in standards has direct and indirect benefits. It increases thought leadership in the region, and for the individuals, it develops both technology and soft skills. And there are various ways to contribute. You can observe, you can contribute, and perhaps progressively you can start observing, you can start contributing, and at some point of time you will be leading working groups and standard committees, right? And this was a quote from Craig Barrett several years back on why it is really, really important to understand global standards, right? So a lot of resources are put together for people to take a look at it in their leisure. I've also written a couple of articles in previous Region 10 newsletters, so you can take a look at that also. So with that, I will, I apologize that I took slightly longer. I wanted to give more than 20 minutes for Q&A, but we at least have about 10 minutes, and I'm happy to stick around for people who have questions and would like it to be addressed. So back to the organizers. All right, so I'm going to go through the chat window, and I'm going trying to take a look at if anybody...
we now come to the question answer. Srikanth, it's come to the end of your presentation.
Correct, sir.
Okay, so we come to the friends. We come to the question answer session. We will take a few questions, and you can put it in the chat box if you have done so. Srikanth, if you want to, I don't think there are much questions.
Yeah, so we will wait for a couple of minutes. Otherwise,
okay, we can wait for a couple of minutes, or we can have a quick 5 minutes break here. You wanted to have a break, but you
no. We don't need break at this point. So
okay.
we can wait for a couple of minutes and then
yes. So
take the next steps. Yeah.
Those who are there online, they can just post their questions in the chat box, and Srikanth will be very glad to answer those questions. Quick questions, please.
And I hope this was useful, Sanjay ji. So.
Sir, actually, I tell you, I have seen many presentations, but this one I've been very, very informative for me. That much I can tell you.
Thank you, sir. Thank you. I
That
appreciate
was the most important thing. Very, very informative. And most of the things we were not aware of.
Yep.
That's the main point.
Correct. I think a lot of times we don't do certain things most often because of lack of awareness. We have a lot of experts, but they do not know how to engage. I think this was pretty useful. So there is one question that has come on my private chat window, Sanjay ji. How do you suggest students contributing to IEEE SA, right? So there are multiple ways for students to contribute, right? And and there are different ways to do that depending on whether it's a pre-standards program or a standards activity, right? In a pre-standards program, and we have several pre-standards program. We have pre-standards program, as I mentioned, on AI, metaverse, medical data interoperability. So there are several of these. So when students connect on a pre-standards program, sometimes what people do is when they are doing these activities, they might give specific focused activities for a bunch of students, to go and work on certain aspects. They can also collaborate. A lot of our pre-standards activities put workshops together. They can engage in putting together the workshop on that particular topic. But as I mentioned in the concluding slides, the best way to connect to experts within the IEEE ecosystem is to sign up to a standards working group, right? And if you want to learn about a particular technology, you sign up to the working group, you actively participate. When I say you actively participate, you might want to learn about the technology, so you don't have to actively contribute, but you can actively observe, right? So when you observe, so what happens is you get to understand how others are thinking, where the technology is heading towards. And sometimes it's a good takeaway for students itself for the research that they are doing, and perhaps an opportunity for contributing the work that they are doing in research as part of the standards working group activities. So there are several ways where students can participate. In fact, more recently, we have also done several focused hackathons and codeathons within the Standards Association. Open source is another excellent opportunity for a student community to come together and do something on the open source platform. So, there are various ways, and this question came from Ankit, I believe. So Aniket Shunai, and I will, if there are further ways, you can send me a note and we can definitely take it up. There is a question from Lance Fung. I'm trying to read. How can IEEE and SA prevent application of technology against humanity, such as violation of human rights? Very deep question, So I think I think it's very timely, Professor Fung. In fact, there is one work that we are recently engaged in with a body within Europe, where we are trying to work with them together on what is the impact of what should be done when we talk about metaverse and human rights. So we are developing a chapter for that, right? So in human rights, of course, is a fairly deep conversation, but in terms of more broadly, right, if you talk about societal impact and how these technologies are impacting the society, I think that is the work that the IEEE 7000 series of standards are trying to do. The idea is to ensure that the work that we are doing are addressing certain procedures. For example, the IEEE 7000, the base work, what it does is it's a checklist, it's a guidance to say that, okay, where there are certain considerations that the vendor went through as part of designing these systems. They look at the unintended consequences. A lot of time unintended consequences are a severe problem. So we are developing a standard, but we are also developing that certification, which actually goes and validates that these things are happening. And I think these are the work that we are doing in XR, we are doing in the IEEE 7000 series of standards, which are really, and the children work, where we are making sure that we are holding people accountable and making sure that they are actually adhering to these standards. All right. Any other questions?
I think one more question has come from Raunak Day.
Yeah, there is a problem with AI with job loss.
Job loss, yes.
Okay. Yeah, I don't know how to answer that question particularly, but I think what has happened is, I can only go anecdotal here. When computers came and, there was a view that computers are going to replace all human beings. I think it went the other way around. As and when new technologies come in, my view is there will be new companies that will evolve. There will be new applications that will come in, and that will require expertise, right? Yes, some aspects of our what we do might move to an automated system. I don't want to take that lightly. But having said that, there will be people who will come with new applications, new ideas, new industry verticals, perhaps, to take this further. There is an array of work that is happening on smart wearables, things that did not exist 10 years back, right? Sensor technology for sportswear, for healthcare. So people come together and design these systems. So my view is, as as part of the evolution, we will start taking on other challenging problems. That is my view of it, but time will tell. Okay. There can be some regulation. Okay, sir. Okay. Raunak Dey has asked me a question, but there can be some regulation by the organizations like IEEE. Okay. So IEEE does not, that's a good point, right? So IEEE does not itself make regulations, right? We are a voluntary body. We develop voluntary standards and voluntary adoption of standards by the market, right? But what we try to do is more and more we are doing that. We work very closely with regulators. So as regulator, because it's a challenge, right? Being in the technology field myself, I know, I'm sure a lot of people appreciate this. Technology is moving very fast, right? So you have to be constantly, abreast with it. So imagine the policymakers and regulators, they have to make decisions on these technologies, and they are one step perhaps removed, right? So we certainly understand their pain point. So what we do is, we are not the regulators. We work very closely with the regulators in trying to see, what is the IEEE's views, and we only provide our views on it. It's ultimately up to the regulators to make regulations, right? They have the ownership, but they do reach out to organizations such as IEEE, get their feedback as they are creating their positions, right? So that's how we get involved and we contribute. All right. I don't see.
I don't see any question answers.
No, I
So-
don't see anything with us.
Can we close the question answer session then?
Absolutely, sir. I just wanted to, the presentation has my email ID. Feel free to reach out to me. I know that a lot of times people would prefer to interact one-on-one, so I'm more than happy to respond. I will commit to Region 10 that all questions that I get, I will send a response.
Thank you. Thank you very much. We now move on to the next part. That's the feedback. All those who have attended today, they can just scan the QR code and give us a feedback regarding your views and what else do you require. And we are also available on our social media, Facebook and others, Twitters. And our next webinars, that's innovation technologies for highly safe and energy efficient GAN devices. That's coming up on the next Saturday, 22nd of April, from 3:30 p.m. to 4:30 p.m. Indian Standard Times. So please be with us. Just wait for 7 days. We are there. We are now move on to the last leg. That's the closing remarks. May I request Mr. Deepak Mathur, who is there as the past Region 10 Director, to make the closing remarks and propose the vote of thanks, sir. Mr. Mathur, please.
So thank you, Sanjay. Thank you very much. And thank you, the 10 Talk team, for arranging such a wonderful presentation. Shri, you presented very well. It was a very structured presentation. And you have generated a lot of interest and curiosity among all of us. And I'm sure that we are going to organize more such programs to satisfy our curiosity and the interest which you have generated. And I really remember that we were talking about 2 years back that standard associations program requires we need awareness on this for our members and non-members also,
Correct.
because it is a very powerful program and it is a very useful program. And I really liked, Shri, the way you started this presentation by talking about 802.11, that Wi-Fi standard, and how it has evolved to get the single standard has evolved to the great extent. And I know we are having somewhere around 1,300 active standards in IEEE today. So, and I also like the way you told us about the importance of standard, about the process, governance, and how to engage with IEEE Standard Association. So we were not aware that whether the members, non-members, or a single member or organization we can associate ourselves with this Standard Association organization. But but your presentation gave us that very thoughtful answer to that question. And I really like that you address that how this we reduce the market risk if we follow the standards, and how we can reduce the cost of the product. And IEEE is way ahead. It's a leader in developing the standards,
That's
which
right.
you presented to your this bar chart. That was very good. I was knowing that the IEEE is developing standards, but we were not knowing that the conformity and this assessment and certification program of IEEE, which IEEE does as a third party.
Right.
So you really threw good light on through your presentation, and you also talked about IEEE Standard Association's open platform, where you talked about reference architecture concept, how it is being used for the development of standards in today's scenario. There were so many things I have listed that to talk that you have really that was new to us, like standards, specification, registries. You talked about that.
Mhm.
We were just knowing about the standards, but how specification and registries are converted into the standards. That was really, and IEEE Standard Association is having training development program on IEEE policies and procedures.
Correct.
So that is going to be very useful. I'm sure that we are going to organize another series on this Standard Association that will really bring more aspects of standards to our participants. And it is not only that this technical person or the policy makers are important, but we have to also engage government. Correct. Through government engagement program, which IEEE is doing very well. Thank you very much, Sri. I really liked your presentation, and we have started this, and probably in next series, as Sanjay was telling, that there is a plan to bring another program on the standards also. Let me remind our participants who are here that Sri told that IEEE today is not only electronics and for electric and electronics engineers. IEEE has embraced several engineering and non-engineering disciplines, and it is now not known as its full name, that the Institute of Electric and Electronics Engineers. It is only known as IEEE. So with this, I would like to thank organizers of 10 Talk, and a big thanks to Sri for delivering such a good talk today. Thank you very much.
Thank you, sir.
Thank you,
Can I
Deepak
make-
ji. Thank you,
Can
Deepak
I,
ji.
can I make one remark here? Just one 10 seconds. So we are organizing 2 webinars from standards with R10. One is focused around energy, renewable energy, which everybody is using today. And another one is focused around AI. So, so we look forward to having you in that. And with the collaboration with R10, we are also putting industry panels, industry sessions at our key R10 conferences, the HTC conference, the IEEE 10Con, and the IEEE 10Sim. So we are having industry tracks around that. So I just wanted to mention that before I conclude. I thank you. Back to you.
Thank you.
Sanjay.
A small memento for Srikanth ji. May I request
you.
Mr. Deepak Mathur to formally hand over the e-memento to him.
Sri, please accept. When I will meet, I will shake hand with you.
Absolutely.
Okay. Thank you very much. Thank you very much. We are just at in the last, very last leg. We must thank our organizers, particularly Dr. Vimonta, Ashwant, Hisham, Anu. We move on to Professor Lance, who has also joined here in spite of his busy schedule and traveling. Thank you, Professor Lance. Thank you, Takako. Dr. Zia has also joined. I have come just a few minutes back. Thank you, Dr. Zia, Professor Takao, Savitya, Jennifer, my entire R10 Talk team, Varunika, Mr. Asthana, Mr. Daniel, Emiliano, and Khanita. Thank you very much for your cooperation in making the R10 Talk a successful one. With this, we come to the end and we conclude firmly with thanking everyone. Thank you very much. So see you next week in the next webinar, in webinar number 3. Thank you.
Thank you all.
Thank you all. Bye.
Bye-bye.
Bye-bye. Bye-bye.